Hello and welcome to the Wigtown Book Festival. My name is Stuart Kelly. I'm a writer and critic, and I blame my parents. I did think as a schoolboy that I would go into the sciences, but they gave me a ticket to the theatre and I ended up doing humanities. So it may have made my life richer in some ways and poorer in others, but I've always kept a toe in science. And Martin Rees, with whom we'll be speaking today and hearing from today, is one of the people whose work I most admire. We were speaking beforehand about his book, 6 Numbers. He is somebody who has looked very closely at the very far away and very particularly at what is going on now. As those of you who've been following the festival throughout the week will know, one of the themes has been catastrophe, apocalypse, desolation, and I think it's quite appropriate that at this point we get somebody who really knows what they're talking about rather than just imaginatively muses upon that. Please give a virtual welcome to Martin Rees. We are going to begin with Martin introducing his ideas. There'll be a 30-minute talk from him, and I'm sure it will be, well, I was going to say a delight. Perhaps it will be a caution, something slightly minatory, but at least we will have something that we can think over and realise the consequences of. So, Martin, do you want to begin?
Thank you very much. It's a great pleasure to be speaking at this festival. So good afternoon, everybody. First slide, please. I'm going to talk about some themes from my book called On the Future. And I start off on what should be my first slide with the famous iconic picture of the Earth seen from the moon, a picture we've had for 50 years. But suppose some aliens have been watching our Earth for its entire history of 45 million centuries. What would they have seen? Over most of that vast time span, Earth's appearance would have changed very slowly. Continents drifted, ice cover waxed and waned, successive species emerged, evolved and became extinct. But in just a tiny sliver of Earth's history, the last 100 centuries, there were human-induced changes, agriculture, urbanization and industrialization, happening much faster. And within the last century, these changes accelerated with runaway speed. The amount of carbon in the atmosphere began to rise abnormally fast, and something else unprecedented happened. Rockets launched from the planet's surface escaped the biosphere completely. Some were propelled into orbits around the Earth, some journeyed to the moon and other planets. But to go back to your question, if they continue to keep watch, what would these aliens watching our planet witness in the coming century? Will a final spasm be followed by silence, or will the planet's ecology stabilize? And will an armada of rockets launched from Earth spawn new oases of life elsewhere? This century is special. It's the first in Earth's history when one species, ours, has the planet's future in its hands. And that's my main theme this afternoon. But first, a disclaimer. Because I have the title Astronomer Royal, I'm sometimes asked, do you do the Queen's horoscopes? And I respond, I've never been asked. I'm not an astrologer. I've got no crystal ball. Indeed, scientists are on the whole rotten forecasters, though not quite as bad as economists. And there are some things that can be predicted. For instance, the world will get more crowded. Any chance of a slide? I've got a nice picture here. Yes, okay. Next slide, please. Yes, okay. This picture shows a distorted map where each country is given an area proportional to the amount its population has grown in the last 30 years. And you see that it's in East Asia and Africa that the growth's been fastest. And world population is forecast to rise to about 9 billion by 2050. It's now 7.8 billion. The growth is partly because most people in the developing world are young. They're yet to have children and they live longer. Next slide, please. The age histogram in the developing world, on the left, will become more like it is in Europe, the one on the right. To feed everyone is going to require improved agriculture, low-till, water conserving, and perhaps GM crops, and maybe dietary innovations, converting insects, highly nutritious and rich in protein, into palatable food, and making artificial meat. To quote Gandhi, there'll be enough for everyone's need, but not for everyone's greed. Population growth is fastest now in sub-Saharan Africa. And as compared to the fatalism of earlier generations, those in poor countries now know via the internet, etc., what they're missing. And migration's easier. And that's a recipe for disaffection and turbulence, especially in Africa. And I think that wealthy nations, especially in Europe, should urgently promote prosperity in Africa, and not just for altruistic reasons. We need a massive Marshall Plan, as it were, to ensure that Africa doesn't fall behind. Humanity's ever heavier footprint jeopardizes the entire natural world. And as we heard recently, the United Nations reports that 10% of species are already at risk. And about 95% of mammals are either humans or animals kept for human food. Wild mammals are just 5%. And to quote the great ecologist E.O. Wilson, mass extinction is a sin that future generations will least forgive us for. We're destroying the book of life before we've read it. Next slide, please. We're clearly harmed if fish stocks dwindle to extinction. There are plants in the rainforest whose gene pool might be useful to us. But for many environmentalists, preserving the richness and beauty of our biosphere has value in its own right, over and above what it means to us humans. Next slide, please. Moreover, pressures on the environment are aggravated by something else we can confidently predict: global climate change, the world getting warmer. Under business as usual scenarios, we can't rule out later this century really catastrophic warming and tipping points triggering long-term trends like the melting of Greenland's ice. The urgency to remove this threat is compelling. But politicians won't gain much resonance by advocating sacrifices now, when the benefits accrue mainly to distant parts of the world and decades in the future. Indeed, conventional discount rates write off anything that happens much after 2050. So governments aren't properly prioritizing long-term measures which are crucial for future generations. And they won't do this unless there's support for voters. And this needs effective campaigning to change the public mindset, because politicians respond to what voters want and what's in their inbox. For example, the papal encyclical Laudato Si had a worldwide impact in 2015. The Pope got a standing ovation at the UN. And there's no gainsaying the Church's global reach, long-term vision, and concern about the world's poor. And because of this encyclical, there was a consensus at the Paris conference on climate in December that year, aided greatly by the Pope's influence on his billion supporters. And to take a more parochial example, here in this country, I doubt that Michael Gove would have become exercised about non-degradable waste in the oceans had it not been for the BBC's Blue Planet programmes, fronted by our secular Pope, David Attenborough, especially the image of an albatross returning to its nest and regurgitating plastic debris, and not the longed-for nourishment for its young. That's as iconic an image as the polar bear on its melting ice floe is for climate campaigners. So politicians respond to public pressure and to the press. And it's therefore encouraging to witness more activists among the young who will live to the end of a century. Their campaigning is welcome. Their commitment gives grounds for hope. Next slide, please. Incidentally, there's one win-win roadmap to a low-carbon future. Nations should expand their research and development into all forms of low-carbon energy generation and into all other technologies where parallel progress is crucial, especially storage, batteries, hydrogen, pumped storage, etc., and smart grids. Because the faster these clean technologies advance, the sooner will their prices fall. And that'll be good for us, but even more important for instance, India, where more generator capacity is needed and where the health of the poor is now jeopardized by smoky stoves in their homes burning wood and dung. And they will otherwise build more coal-fired power stations. So it will be hard to think of a more inspiring challenge for young engineers than devising economical clean energy systems for the world. And it will be in the UK's interest to spearhead this. We generate less than 2% of the world's CO2 emissions, so meeting our 2050 targets makes only a tiny difference. But we have maybe 10% of the world's clever ideas, so if we exploit those, we can perhaps make more difference to the world. Incidentally, it's engineers, not scientists, who will do this, and I should emphasize that I'm a scientist, but I should respect engineers, and engineering friends, and there may be some in the audience today, they like a cartoon which shows two beavers looking up at a big hydroelectric dam. And one says to the other, I didn't actually build it, but it's based on my idea. And this reflects the balance of effort between armchair theorists and scientists who just have the idea and the engineers who actually make things that work and are affordable. And they're what we need if we are to meet the world's carbon targets. We shouldn't be Luddites. Without new technology, the world can't provide clean energy for an expanding and more demanding population, nor enough food, nor better health. But efforts must be widely directed. Indeed, many are anxious that bio, cyber, and robotics are advancing so fast and so unpredictably that they may have the risk of giving us a bumpy ride through this century. So a few words about some of these issues. Next slide, please. This is not the coronavirus, it's the flu virus. And I show this because in biotech, new techniques for gene editing are hugely promising. But ethical concerns are already raised by, for instance, Chinese experiments on human embryos. And I show this virus because experiments done in 2011 in America and in Holland showed it was possible to engineer the flu virus to make it more virulent and more transmissible. These experiments were banned for a few years in the United States because obviously they're dangerous. And if they could be done on the coronavirus, which is more complicated, that would be an even worse scenario. And also regarding biotech, next slide, there are concerns about what's called gene drive programs. These can make a species sterile and help to wipe it out. And they've been used benignly to wipe out the species of mosquito that carries the Zika virus in South America. But some nasty people want to use this to make the grey squirrel extinct so that the brown squirrel can survive. But if you do that sort of thing, then of course there's a risk of runaway consequences and disturbing the ecological balance. So you've got to be very careful in how we apply these new techniques. And these are concerns, engineering viruses and gene drive in the next 10 or 20 years. But let's look further ahead to 2050 and beyond. The great physicist Freeman Dyson foresees designer babies and conjectures a time when children will be able to design and create new organisms just as routinely as he, when a child, played with chemistry sets. If it indeed becomes possible to, as it were, play God on a kitchen table, our ecology and even our species may not long survive unscathed. So biotech will need regulation. And so indeed will AI and other technologies, because their downsides are not just unethical, but potentially catastrophic. But my worry is that it's not like nuclear technology, where you can't make a bomb without huge special purpose facilities that can be easily monitored by international bodies. You can use modest scale dual use equipment available in many labs and in university industries to create some bioweapon. And of course, cyber attacks can be carried out by loners and small groups and are becoming potentially more catastrophic too. So a dangerous trend is that these new technologies, bio and cyber and AI, are empowering small groups to have effects that could cascade globally. And I worry that whatever regulations are imposed can't be enforced worldwide any more than drug laws can or the tax laws. And whatever can be done will be done by someone somewhere. And the global village will have its village idiots, and their actions can cascade globally with catastrophic effect. It's a wise mantra that the unfamiliar is not the same as the improbable. These things haven't happened once, but once is too often. And I think the rising empowerment of groups or even individuals who are tech savvy in bio and cyber will pose an intractable challenge for governance and aggravate the tension between freedom, privacy, and security. And what about artificial intelligence? There have been huge advances in machine learning. Computers given no more than rules of the game can learn within a few hours to play chess or the game of Go better than any human. Next slide, please. And that's essentially because, as you all know, computers have the advantage of speed. They're getting faster and faster. This allows them to process and analyze huge amounts of data. They can learn to play chess by playing against themselves several games per second and become as good as a grandmaster in 3 hours. And of course, they could do other things by brute force methods. They learn to identify dogs, cats, and human faces by crunching through millions of images, not the way babies learn. They learn to translate by reading millions of pages of, for example, multilingual documents, like those from the EU. They never get bored. Well, the implications for individuals of AI are already ambivalent. If we're sentenced to a term in prison, recommended for surgery, or even given a poor credit rating, we'd expect the reasons to be accessible to us and contestable by us, as they are if they're given by a human. But if such decisions were entirely delegated to an algorithm, we'd be entitled to feel uneasy, even if presented with evidence that on average, the machines make better decisions than the humans they've usurped. So I think AI systems will become more intrusive and more pervasive. Records of our movements, our health, and our financial transactions will be in the cloud. The data may be used for benign purposes, for instance, medical research, or to warn us of incipient health risks, but its availability to internet companies is already shifting the balance of power from governments to globe-spanning conglomerates. And there'll be other privacy concerns. Are you happy if a random stranger sitting near you in a restaurant or on a train can, via facial recognition, identify you and invade your privacy? Or if fake videos of you become so convincing that visual evidence can no longer be trusted? So these are some downsides of the advance of AI. And another big question is, will this new machine age be like earlier disruptive technologies, the car, for instance, and create as many jobs as it destroys? Or is it really different this time? AI won't just take over manual work. Indeed, plumbing and gardening will be among the hardest jobs to automate. But routine work in legal offices, computer coding, and even surgery and medical diagnostics may be taken over. Next slide, please. This is my recent book on the future, and I argue in this for massive redistribution of wealth from the robot owners to create in huge numbers secure and respected jobs where human empathy is crucial. We want a real person to look after us when we're old or sick. We want small children to be tended and told stories by real people, not automata. Such jobs are more satisfying than those that they will usurp in call centers or Amazon warehouses. And incidentally, what we've learned in the course of COVID-19 is that the really important jobs like bus drivers, delivery drivers, and care workers are grossly undervalued. We need a massive redistribution towards them, and that could come if the companies that make the AI are taxed appropriately. And AI, of course, can do other things well because of its speed. It can cope with fast changing networks, traffic flows, electric grids, etc. And it's advancing fast. And indeed, the Chinese could soon create an artificial, efficient planned economy of the kind that Marx could only dream of, because they've got the information on everyone's transactions and the stock in every shop. But let's speculate further ahead. What if a machine developed a mind of its own? Would it stay docile or go rogue? If it could infiltrate the Internet of Things, it could manipulate the rest of the world. And it may have goals utterly misaligned to human wishes. Well, some AI pundits take these scenarios seriously, and they think the field already needs guidelines, just as biotech does. But others think it'll be a long time before we need to worry more about artificial intelligence than about real stupidity. But watch this space. We need to know how fast machines do take over things that were the problems of humans. Now a word about my special interest, space, because it's beyond our Earth, in environments hostile to humans, that robots and AI have the most spectacular scope, and in my view, raise fewest concerns. Next slide, please. The Apollo program, Neil Armstrong's one small step on the moon in 1969, was a heroic episode. And I treasure this picture signed for me a few years ago by 7 of the Apollo astronauts. But to today's young people, it's ancient history. They know that the Egyptians built pyramids, they know the Americans landed on the moon, but these both seem strange activities motivated by strange national goals. And of course, the momentum of manned spaceflight was lost when the Americans had beaten the Russians to the moon. If the Americans had gone on spending 4% of their federal budget on space, as they were doing during Apollo, there'd have been footprints on Mars long before today. But manned spaceflight has rather languished, but of course, space technology has burgeoned for communication, environmental monitoring, sat-nav, and so forth. We depend on it every day. And unmanned probes to other planets have beamed back pictures of varied and distinctive worlds. Next slide, please. Right. Well, as robots and miniaturization have improved, the practical case for sending people into space has actually evaporated. If people go, it will be just as an adventure. And I don't think taxpayers should fund them. It's far more expensive to send a person and to bring them back than to send a robot. And it's especially expensive if it's done by a Western government, because they're so risk averse. And the space shuttle failed twice in 135 launches, less than 2% failure rate, but even that was unacceptable. And each of the two failures was a big national trauma in America. So my view is that manned spaceflight should not be paid for by taxpayers. If I was an American, I wouldn't pay for it at all. I wouldn't want to. It should be left to private companies like Elon Musk's SpaceX, because they could run a cut price program far riskier than Western nations could impose on publicly supported civilians. And they'll get people to go, even perhaps to Mars with a one-way ticket. And certainly by 2100, thrill seekers, people in the mold of, say, Sir Ranulph Fiennes, may have established bases independent from the Earth, probably on Mars. And Elon Musk himself has said he wants to die on Mars, but not on impact. He's 49 years old now, so he might make that himself. But although there'll be a few people on Mars by the end of the century, don't ever expect mass emigration there. And on this, I disagree strongly with Musk and with my late colleague Stephen Hawking. I think it's a dangerous delusion to think that space offers an escape from Earth's problems. Coping with climate change here on Earth is a doddle compared to terraforming Mars. Nowhere in our solar system offers an environment even as clement as the Antarctic or the top of Everest. There's no planet B for ordinary risk-averse people. Next slide, please. But if a few brave adventurers want to live on Mars, we should cheer them on. And this is why. Because they're an inherently hostile environment for humans, they'll have far more incentive than us on Earth to redesign themselves. They'll harness the super powerful genetic and cyborg technology that will be developed by the end of the century. These techniques will be heavily regulated on Earth, but they'll be far beyond the clutches of the regulators. So it's these spacefarers, not those of us comfortably adapted to life on Earth, who spearhead the post-human era, evolving into a new species. Next slide, please. Next, please. But even on Earth, future evolution will surely happen far faster than Darwinian evolution did. We're heading for an era where human beings themselves, their mentality and their physique, may become malleable by genetic modification and cyborg technology. This is not a game changer. When we admire the literature and artifacts which have survived from antiquity, we feel an affinity along a gulf of thousands of years with those ancient artists and their sages. But we can have zero confidence that the dominant intelligences a few hundred years from now will have any emotional resonance with us, even though they may have an algorithmic understanding of how we behaved. Next slide, please. This is the futurologist Ray Kurzweil. He's especially gung-ho about all these advances. His book, The Age of Spiritual Machines, predicted that humans would transcend biology by merging with computers. In old-style spiritualist parlance, they'd go over to the other side. But Kurzweil's worried that his nirvana may not happen in his lifetime. So he wants his body frozen until it's reached. There's a company in Arizona that'll freeze your body in liquid nitrogen. So when immortality is on offer, you could be resurrected with your brain downloaded. Now, I'm surprised to find that 3 academics in England had gone in for this cryonics. 2 had paid the full whack, 1 the cut price for just having his head frozen. And glad all these 3 were from Oxford, not from my university. Because I told them I'd rather end my days in an English churchyard than an American refrigerator. Well, this is a festival of science and the arts, so I'd like to venture a few thoughts on the scientific endeavour in general. What have we learnt? What might we learn? What might we never know? Next slide, please. Next one. Yes. We've learned that all cosmic processes are interconnected. Not only do humans share a common origin with the entire web of life on Earth, but we depend on the stars. Life's energized by light from the sun. We're made of atoms that were forged from pristine hydrogen in faraway stars long ago. We're nuclear waste from the fusion reactions that make stars shine. Much we understand, but we find that there's much that still baffles us. And one key question is, are the things that we will never understand? Our human intuition evolved to cope with the conditions our remote ancestors had to cope with on the African savannah. Our brains haven't changed much since that time. And it's amazing we've made so much progress understanding the counterintuitive world of the atom on the left of this picture and of the stars on the right-hand side. But the challenges of physics and cosmology aren't the only ones. The smallest insect has far more intricate structure than a star or a galaxy. Indeed, people are sometimes surprised when I say that, odd though it may seem, some of the best understood phenomena are far away in the cosmos. I could speak with great confidence about black holes a billion light years away crashing together. In contrast, our grasp of some everyday matters that interest us all, diet and childcare, for instance, is still so meager that expert advice changes from year to year. That's not because astronomers are clever, it's because the big and the small are much less challenging than the very complex intermediate scales, especially the biological world. Indeed, perhaps we never understand the mystery of our brains, how atoms can assemble into grey matter that can become aware of itself and ponder its origins. Next slide, please. This time chart showing the 4 billion years over which we've evolved from the simplest life are now part of common culture. But astronomers are aware that there's as much time at least lying ahead as there is now. Many people look at this time chart and think that we are the culmination of this evolution. But no astronomer could believe that. So next slide, please. This next slide shows that the time lying ahead is even longer. The sun's been shining 4.5 billion years. It's got 6 billion before it flares up and dies. And the expanding universe will continue perhaps forever. To quote Woody Allen, eternity is very long, especially towards the end. So we may not be even at the halfway stage in evolution. It won't be humans who witness the sun's demise. It'll be entities as different from us as we are from slime mold, either organic or electronic. But even in this concertina time perspective, it's the first, this century is the first in the hundreds of millions of centuries that the universe will exist for, where one species, ours, can determine the planet's fate. We could be of cosmic significance for jump-starting the transition to electronic entities, spreading their influence far beyond the Earth, or we could leave a depleted and devastated planet that forecloses these potentials. We just don't know. I started with a cameo of the Earth, seen from space, and I'll end with another. Next slide, please. Next slide. Yes, here we are. This is motivated by this great building, Ely Cathedral, just about 12 miles from where I live in Cambridge. And I want to express the thoughts that strike me whenever I visit this wonderful place. For medieval people, the entire cosmology, from creation to apocalypse, spanned only a few thousand years. They knew of nothing beyond Europe. Many of them had never been beyond the Fens. But despite these constricted horizons, in both time and space, despite the deprivation and harshness of their lives, and despite their primitive technology, they built this immense and glorious building which they would never see finished in their lifetime, and one that still elevates our spirits centuries later. What a contrast this is to so much of our discourse today, because unlike our forebears, of course, we know a great deal about our world, and indeed about what lies beyond. We know that we are stewards of a precious pale blue dot in a vast cosmos, a planet with a future measured in billions of years. So it's shameful that our planning horizon is shorter than that of our medieval forebears. It's actually not quite such a paradox, because although the medieval Masons thought the earth might last more than 1,000 years, they thought their children and grandchildren would live lives rather like their own, and that they would appreciate the finished cathedral. Whereas now, despite our vast horizons, things are changing so fast that we can't be sure that 50 years from now, people will have the same values and same preferences and same lifestyles as us. And that perhaps isn't a problem which justifies why it's hard to plan ahead. But next slide, please. Spaceship Earth is hurtling through the void. Its passengers are anxious and fractious, and their life support system, as I've indicated, is vulnerable to disruption and breakdown. There's too little horizon scanning to minimize long-term risks. And we need science, but guided by values that science can't itself provide. And that's, I think, a key message for all of us. We need what some people call cathedral thinking, if we have to plan far enough ahead to avoid the dangers that otherwise may engulf us during this century. So let me stop there. Thank you very much for listening.
Thank you, Martin. That has been a fascinating and extremely cogent and lucid talk about futurology. Too often it seems that we have either the blue sky thinking of somebody like Elon Musk, who, if he wants to go to space, can, or the catastrophism that we see around about us. Yeah. I'd like to begin just by asking about when you were previously thinking about what the future might be like, there were certain things that you identified as potential threats. Mm-hmm. Artificial intelligence, asteroid strikes, runaway viruses, indeed, even nuclear war, mm-hmm. climate change and catastrophic effects on the environment there. Mm-hmm. When you look at that again, do you think your pessimism or optimism has changed about any of them? Is nuclear less of a threat now than it was? Is the idea of a virus more of a threat than it was?
Well, let me say two things. First, asteroids, of course, we can quantify what that risk is. It's very small. It's worth a bit of effort to reduce it, but it's a very small risk. And importantly, it's not getting any bigger. The rate of impact is the same, more or less, now as when the dinosaurs got killed. So it can be disastrous, but it's rare. But the threats that I think worry us are those which are caused by humans. And they're in two categories. They are those which we cause collectively, which is climate change, loss of biodiversity, etc., and those which are caused by individuals or groups or nations. And that I mentioned bio and cyber. But as regards nuclear, of course, the first really existential threat was nuclear war. And during the Cold War, I think it was the greatest threat that we in Europe were ever under, because at the time of the Cuba crisis, well, those like McNamara in their reminiscences claimed that they were lucky rather than wise to avoid a catastrophe. And Kennedy put the odds at between 1 in 3 and evens. So nuclear war during the Cold War was a real threat. And I just wonder if people would have been so happy with the mutual assured destruction strategy if they'd really known how dangerous it was. So that threat is somewhat in abeyance. There's probably more risk that a nuclear weapon will go off now somewhere in the world than before, due to regional conflict. India, Pakistan, Middle East, North Korea, etc. But that would be a regional rather than global catastrophe. And indeed, there are 10 times fewer nuclear weapons now than there were at the height of the Cold War. So that's in abeyance, but only temporarily, because there could be a standoff later this century between two superpowers, which is handled less well or less luckily than the Cold War was. So the nuclear danger is always with us, but it's now aggravated by these rather less controllable threats from bio and cyber.
I shan't press you on which two superpowers there might be in 80, 90, 100 years' time. Can we go on to the whole idea of runaway consequences? That it's so difficult. I mean, science does rely upon prediction, something which is, if you do the same experiment 5 times, you get the same result 5 times. When we're talking about human situations, there are so many factors, it is almost impossible to see what all the consequences are. So how does one mitigate against runaway consequences? Is it just to do less, but do it more carefully?
Well, I think there's some where we know what to do to mitigate. I mean, climate change and loss of biodiversity. I mean, we know what needs to be done. It's just hard to motivate it because it requires global altruistic action for the benefit of future generations, which is hard for politicians to prioritize over the urgent and the parochial. So those are cases where we know what to do. But of course, as we've seen in the present pandemic, we didn't know how best to handle it. This country was quite well prepared for another influenza pandemic, but it hadn't prepared for this rather different kind of pandemic where protective clothing was crucial, etc., and etc. So I think what we've learned is that it would have been worthwhile preparing much more extensively for not only the type of crisis that happened, but a number that didn't happen, because thinking globally, the cost of this pandemic is going to be measured in probably tens of trillions of dollars. And in that context, it would have been worth spending hundreds of billions of dollars as a sort of insurance premium, because no one could have said that this type of event was highly improbable. It was unpredictable when it would happen and exactly what it would be. But given that we'd had not only flu pandemics, but also SARS and MERS, it wasn't something which was that unlikely. And if you'd asked most people, they would have said that there's a chance of it happening in the next 20 years, or something like that. So I think we have learned that we can prepare for these things, and also cyber attacks and bioweapons we can perhaps prepare against. So we're moving into a dangerous century, but I think we can do more. But I am pessimistic because I don't think we can eliminate these risks completely. And certainly not without having utterly intrusive surveillance, so we know exactly what everyone is doing all the time.
Which in itself is a kind of threat. I'm going to start on some of the questions coming through from the audience. One member is asking about what you think the importance of the cultural is as we move forward, I presume, as opposed to the technological. Mm-hmm. So is culture a way that we can negotiate our way into the future?
Well, I mean, I think culture is a crucial part of being human, to appreciate it. But I think one point I would make is that when we talk about science, science is, of course, crucial for understanding the world and the basis of all the technology, without which we couldn't feed the present world's population, etc. But also it's a common culture. Understanding about what Newton and Darwin and Watson and Crick did is part of culture, and it's the one truly global culture. There's protons and proteins are the same all over the world, so that's why scientists, of course, as we know, collaborate very easily, and also that they're able to straddle boundaries of nationality and faith more easily than probably other kinds. So science is in a sense a part of culture. Of course, the sad thing is that some of science is rather arcane and difficult to understand without special preparation. But I think Darwin was probably the last person who could write his great ideas in a work of literature at the same time. That can't be done, but it's certainly possible for the key ideas of science to be presented in a way that anyone can understand. I mean, the technicalities can't be, but they're only important to the specialists. And the key ideas, I think, can be expressed in language that most can understand. And I think it's very important this should be done. And it's a part of our culture.
I completely agree, and I've never really bought the C.P. Snow argument that there's two cultures. I think Ezra Pound's cantos are just as difficult as Stephen Hawking's Brief History of Time. But another question here. Somebody's saying, it's a fascinating talk. Every tool is a weapon if you hold it right. The problem isn't what humans create, but what they do with it. Do you think our problems are more psychological than technological? And where will that psychology lead us?
Well, they're psychological and ethical, and that's why I said right at the end, we need to develop science in a benign way, using values that science itself can't provide. And I think that's crucial. That we need a value system, and science can't give us a value system, despite what some people say, in my opinion. We do have to ensure that science is developed in a way that is both prudential and ethical, and that is the hard thing. And of course, it does depend on human psychology, which we can't change. But of course, I think the fact that if there is disaffection and discontent among the public, the downsides are now much more serious. Gives us an added incentive for trying to minimize those disaffections, because we now know that it's possible for a few people to create a catastrophe if they're disaffected, and people in a country which is lagging behind may feel aggrieved in a way it did in the past, because they know what they're missing in the rest of the world. And so I think that there are extra motives now for trying to ensure that those people who are disadvantaged don't fall behind to the extent that they have been now. Inequality has been growing, both within countries and, in a sense, between countries. And we've got to make sure that just as the care workers have more secure, better paid, more highly esteemed status, so the countries of Africa aren't allowed to lag behind in their welfare to the extent that may happen if we don't do anything.
One question has come through, and it's a really fascinating one. People are extremely enthused about what you've been saying. But the question is, how do scientists like you influence our politicians, our rule makers?
Yes, well, that's a very good question, because I mean, I know lots of people who have been science advisors in government in this country and in others. And of course, they have a frustrating time because the politicians have an urgent agenda, and it's hard for them to focus sufficiently on something which is long-term and potentially global when they worry about immediate clamours from their voters and what happened before the next election. And Mr. Jean-Claude Juncker said in a different context about politicians, we know what we have to do, we don't know how to get re-elected if we've done it. And so that's why scientists interacting directly with politicians tend to get sidelined in favor of more urgent things. And that's why, as I mentioned, it's very important that scientists should enlist charismatic figures to amplify their voice via a large public. Because if a large public cares, as they're coming to over climate change and post-David Attenborough about plastics in the ocean and things like that, then the politicians will respond. And so I think it's an important obligation of scientists to not only interact with the politicians, but to engage with the public whenever their work has potential social implications, and try to maximize the benefits and ensure that the public is aware. They should do this because the politicians won't take any notice unless there's a lot of people who care. And also the other reason is that if you're a scientist and you discover something which has important implications, then you should tell the politicians, but you are an expert in science. You are just a citizen when it comes to politics, ethics, and economics. And so you shouldn't have more voice than anyone else, and everyone else should have an equal say in how your work is applied. And so that's another reason why it's important that everyone should have some feel for science. And the trouble is that not only are many people not interested, but they don't have enough grounding in science for these debates to get above Daily Mail slogans, which is not very illuminating. And so that's the reason why I think everyone should have a feel for science. That's not the same as being an expert scientist. We don't have everyone to become scientists, but just as you can be appreciate music, even if you can't compose it or can't even read or perform music, likewise, you can understand the basic conclusions of science and what it tells us about the world we live in without being an expert. And I think we can aspire to ensuring that all citizens have that sort of basic comprehension.
It strikes me that if we want the rounded humans who will shape a future for the future's future, things like the baccalaureate or the Scottish old higher system are far more effective. The fact that I could study science and humanities at the same time, rather than be pushed down to 3 sciences, or, you know, that was a privilege, is the only word to describe it. And I think the educational spectrum needs to be broadened. It's not right that there are people in humanities who know nothing about science, nor is it right that there are scientists that really don't know about the cultural history. The way you talked about Ely Cathedral was immensely moving there.
Yes,
there's one more.
Yeah, because on that, I mean, I certainly fully agree with you, and I think there were failed attempts in Thatcher's time and also in Blair's time to broaden the sixth form curriculum in England. And they were sort of squashed, even though most teachers supported them. And I think there is a problem. We need to have another go and have something like the IB. But of course, universities have to play their role, because the university curriculum is too specialized for most people. It's not right that 40% of people are doing 3 years full-time education in some rather specialized area. We ought to have a more pick and mix option. And that's one respect in which I think the Ivy League places like Harvard are better than British universities. Yeah. So I completely agree with you. We've got to bang on about greater breadth, but it needs cooperation between universities and schools.
Superb. There's another question through. I'll just get it up. Do you think that dangerous delusion is a genetic human fault anyway? It seems apparent in ordinary daily life to me. Are we just hardwired to being wrong?
I don't think so. I think we've got to accept that the problems we've confronted with are unfamiliar, and they're certainly not what we evolved on the African savannah to cope with. And our mentality hasn't changed very much since that time. And that's why I think we can't cope optimally with these new challenges. Of course, some will say, well, we've got to have a brave new world and change people, or look forward to what I've said, having a world a few hundred years from now where people have different mentalities from humans. But I think we do need to try harder to actually cope with this very strange world where the things we have to worry about are very unfamiliar and very different from what we were programmed to cope with. And also our aggression is not appropriate now in the way it might have been in the past.
We're almost at the end of this, and although we've been talking about futurology and the way in which you've sort of analysed potential threats, potential possibilities of the future, of course, most of your work has been on rather more distant things,
right?
Black holes and quasars.
Yeah.
You mentioned Elon Musk and the idea that we should just give space up to the capitalists.
Mm.
And I wonder, would you like to stand on another planet? Or are you content with your own garden, as Voltaire would put it?
Yes. Well, let me say it's only publicly funded manned spaceflight that I'm against. I mean, clearly we want to make use of space every day, as we do now, from sat-nav communication and the rest, and to explore the universe by probes to the planets and all that. We want to do that, but I think as a human, I am fairly well adapted to the Earth, but certainly not to Mars. So I would be happy just to observe Mars through virtual reality and not go. But if I could have one final word, no one's asked the question which I normally ask as an astronomer, which is there life out there already? And I think it's a very important question. You know, if you think of the far future, is the rest of the galaxy awaiting our progeny, or is there a lot of life out there already? We just don't know. But this is going to be one of the most exciting areas of science in the next 10 or 20 years, because we're understanding more about how life began on the Earth. We're discovering that most stars have planets around them. So there are in our Milky Way galaxy probably 1 billion planets rather like the Earth. The question is, was life such a rare fluke it only started in this one place, or did it happen out there? We just don't know. But I think we're going to find in the next 10, 20 years answers to that question, and we'll find either that we're unique, in which case what happens to us on this planet is a cosmic and not just terrestrial disaster, or we will find that we're part of a cosmos which is far more interesting because it's teeming with life. And as we know the answer to that within 20 years.
That is the question where either answer, are we alone or are we not alone, is metaphysically terrifying.
Yes. Mm.
If we are alone, then we have much greater a burden of care. If we're not alone, and as was famously said by, was it Fermi, why haven't they been in touch yet? We're just too boring to be noticed.
Yes, but just one footnote to that. I mean, I think some people use the Fermi argument to say that there can't be a lot of life. They would have come here and eaten us or something long before today. We some would have had a head start over us if they formed on around stars older than the sun. But I think the point is that if we think of the future, the next 4 billion years, it may be electronic life rather than rather than Darwinian evolution. And it will be sort of what I call secular intelligent design. It'll be creatures perhaps designing more elaborate ones, maybe electronic, and they'll be near immortal. And they'll be very different because whereas Darwinian processes favor intelligence and aggression, there's no particular reason why these post-human entities, some sort of brains, are aggressive at all. They might just be contemplative. So they might be out there thinking hard, but not disturbing us. We've got no idea what it will be like, but we can't assume that it'll be a sort of struggle for existence, which is Darwinian, when we are talking about entities which in some respects are superhuman.
Well, Martin, it has been an absolute joy to speak to you. My spectral ghosts round about me are saying that the hour is up and we have to finish. But thank you so much for taking the time for being here. Please buy Martin's books through the Wigtown bookshop because that supports the festival. And I hope there's a good future for both of us.
Okay.
Thank you.
Thank you very much for the time.